Hello and welcome back. Today we're going to be discussing the topics of bushing, and ball joints. Ball joints, upper ball joints, lower ball joints, upper ball joints, lower ball joints. And believe me, there's a ball joint in there. Let's start off with ball joints. What are they and what do they do? Well, the ball joint was a development in steering and suspension systems that allows for the articulation of the suspension so the tire or the wheel can travel up and down, and while it's in its suspension travel, it also allows the steering to pivot that wheel at the same time. Previously, this was done through the use of kingpins and trunnion bearings, if it was a four-wheel drive application, where the kingpin was the pivot point of the steering. But it didn't offer any articulation other than just pivoting the steering. There are examples of this in the lecture slides. Ball joints are comprised of a tapered stud. Most often it's going to be a tapered stud with a ball socket on the end. There are other joints in the steering and suspension system that resemble ball joints, but are other types of ball stud components. We'll get into that a little more in the steering linkage, but ball joints are comprised of a few parts. So this is one that's assembled. There's a piece that's missing here, and it's the rubber dust boot that seals the grease into the ball joint assembly. So the ball joint often consists of an external body, and it has a spring-loaded end on it, and then a pivoting ball stud on the inside. So this external body, or this cup, is crimped around the top during the manufacturing process and locks this piece inside. The ball socket not only allows it to pivot, but as the suspension goes up and down, there's no binding happening right here. So ball joints allow for steering and suspension movement. Ball joints can be loaded or unloaded. Depending on the type of suspension design on the vehicle, will determine whether or not there is a loaded ball joint in the system. Some vehicles can have 4 ball joints on one side of the front of the vehicle. You may or may not find a Zerk fitting in order to add grease into the ball joint. This is a typical maintenance procedure done at the time of servicing the engine oil and filter and going around to all greasable locations on the chassis and pumping a little bit of grease into them just to make sure that everything is well lubricated and nothing is generating too much friction on the surfaces and wearing out. You may also find ball joints that have no greasable fittings on them, or they may look slightly different because these can interfere with other components, and they may be more of a low profile design, but you're also likely to find ones that are not serviceable. Now, the two major differences in the way that these are going to attach on a vehicle depends on the shape and profile of them. You can see this one, where it's narrower towards the threads and wider towards the ball socket end of it. Whereas this one is straight. This also has a crescent cut out of it, and that's to help lock it in place. With the tapered style, this would tighten into and seat inside of a tapered hole on the component that it attaches to, or that attaches to it. Much like on this aluminum steering knuckle, this hole is wider down here than it is up here. So it's a tapered hole that accepts the matching tapered ball stud component, in this case the ball joint. The ball joint stud would come up through here, and then a nut, and often a cotter key or a crush nut or a lock nut, would hold it in place, and that tapered seat makes it a very tight fit. Over time, as those components wear out, as the ball joint wears out, that will need to be separated in order to service the ball joint. And the ball joint will have to be shocked by striking the component that surrounds it on the tapered bore with a hammer. And it's not a light tap, it's a heavy blow. That we'll go over during lab and address exactly how these separate from each other the easiest way possible. The other style, with a straight stud on it, doesn't have that taper to help lock it in place. The load through a ball joint is carried into the stud. so there's no binding between the body and the stud itself. In order for this style to lock into place, when it is installed into a vehicle, the component will have two ends that almost touch, and these ends allow that hole to open a little more and close. What this uses to lock it in place is called a pinch bolt. And that pinch bolt does exactly as the name suggests, and it pinches those two halves together where they're separated. And as it passes through from one side to the other to clamp that around the stud, the shoulder of that bolt is going to ride in this crescent relief that's been machined into the stud of this ball joint. So that does two things. It clamps the component around the stud, and while clamping it, it's providing a surface, a shear surface, so that this ball joint cannot go up or down. So it can't uninstall and it can't further jam into the component. Since these don't have a tapered seat, once you loosen the component and free the shank or free the ball stud, then it allows for the ball stud to be removed. Now, of course, not accounting for things like rust and corrosion and other types of damage that you may likely come across when working on steering suspension systems. This all lives under the vehicle, so we're talking best case scenario, it's going to be nice and pretty. Worst case scenario, you may have to cut some stuff out and replace major components. So we'll do our best to cover a wide range of possibilities. Now, while ball joints should be able to pivot and move with the suspension articulation, they shouldn't be loose. This one is nice and tight. There's no play in it. If I take a wrench and put some leverage on it, I can make it twist. I can make it move as if the suspension were moving. You can see that it easily supports the weight of the vice grips. We can make that ball stud pivot or articulating. This particular ball joint has been riveted into the lower control arm. So in order to replace this, these rivets would have to be ground out or drilled out in order to uninstall this or remove it from the component. Most of the time, a new ball joint that is made to mount into the control arm in this matter will come with replacement hardware or fasteners or bolts to replace where the rivets go instead of having to rivet a new one into place. You may have to, it depends on the application and what's available. Ball joints are one of those components that are necessary for the wheel to be in line with the suspension and for the vehicle's weight to be put through the tire and support the vehicle. If a ball joint breaks or fails completely, then there's no control of the steering or the suspension on the vehicle. Typically that corner of the vehicle will allow the tire to fling all the way outward. It may cause a strut to deflect all the way outward. Once you lose that pivoting point of the suspension and steering, there's no stability and there's no control of the vehicle. So if one of these breaks while driving a vehicle, there's no limping to the side of the road. It's more of an uncontrolled path of momentum until the vehicle stops on its own. So there's zero control over the vehicle, and it's going to likely cause excessive damage if these were to fail. So they are a very important item of maintenance and safety to keep an eye on when you're doing your inspections and recommending work that needs to be done on a vehicle. This McPherson strut example is a very common example of what you'll find on most front-wheel drive, even all-wheel drive vehicles. It's a very popular and cost-effective design. On this example, our strut, or strut mount bearing, is our upper pivot point of our steering. Down at the bottom, we have a lower ball joint located right here. So the steering of the vehicle is allowed by the ball joint, and that ball joint is connected to the lower control arm. This control arm attaches to the chassis at 2 points. The 2-point contact with the chassis and the 1-point contact at the pivoting point for the steering and suspension means it has 3 points of contact. Triangles are very strong, rigid geometric shapes, and they don't require additional support. As this control arm travels up and down with the movement of the suspension through the spring of the vehicle, that movement is going to be going through this ball joint while still supporting the alignment of that wheel and tire assembly of the suspension. It's the lower pivot point in this case. Now, when we're talking about loaded versus unloaded ball joints, the best way to determine which one is loaded and which one is unloaded, or the loaded component of the suspension, meaning which part of the suspension is supporting the vehicle weight. Bolted to the outside of the rotor and hub assembly here would be our wheel. Connected to the tire, the wheel and tire assembly roll across the ground. So the weight of the vehicle is on the tire, we know that. And the ground is pushing up with the same amount of force as the weight of the vehicle pushing down through the tire. Newton's third law, equal and opposite reaction. So that force from the ground supporting the vehicle is coming up through the wheel and tire, mounted to the hub flange. The bearing is being supported by the steering knuckle. It's this cast assembly here, which has the steering arm for our steering capabilities. Houses the drive axle and the bearing and mounts to the strut up on top, and has mounts for the lower control arm at the ball joint. If we follow the path of force from the ground to the vehicle, in order to determine if it's where the loaded component is, we have to go through the spring, because the spring is what supports the weight of the vehicle. In this case, it's a coil spring on a strut assembly. So if we follow that force coming in from the wheel into the steering knuckle that's connected to the strut to the spring. So the weight of the vehicle is going through the spring. This is our suspension system. And then our upper pivot point is, in this case, the upper strut mount bearing. So in this example, we have one ball joint and it's not loaded. What is it doing though? It's keeping this whole assembly from flopping one way or the other. There would be no structural integrity if that ball joint was not connected. So identifying loaded versus unloaded. It takes a bit of practice and it's easier to do in person. So again, something we'll cover more thoroughly in lab, but keep that in mind as we're working through some of these different systems and identifying the different parts. Ball joints can be configured in a couple different ways. One of those is being under compression load. So here we have a control arm that on these two bushings here, bushings, as this pivots on those bushings, if this is the lower control arm and we have the weight of the vehicle coming down on top of this, then this would be under a compression load. If this was an upper control arm and this was attached to the component up here and this was another pivot, was the upper pivot point, this would be under tension load. So the component would be trying to pull away from the body, rather than the other configuration where the component would be forcing towards the body. So you have compression loaded and you have tension loaded. On the front suspension of the 2005 GMC Sierra, we have an upper control arm and a lower control arm. Our lower ball joint, which is located right here, and our upper ball joint, which is located right here. The lower control arm is connected to the torsion bar on the back side of the control arm. So our force comes up through the wheel and tire assembly into the lower ball joint, through the ball joint. So from the steering knuckle in through the ball joint into the lower control arm, and then out to the spring that supports the load. So the weight of the vehicle is being supported by the lower ball joint and it's under compression load. So this is the force that's acting on that ball joint. The upper ball joint provides our upper pivot point for the steering on the suspension system. This is an example of a SLA or short long arm suspension. So the top ball joint is under a compression load and is only loaded to the point of stabilizing the alignment of the steering and suspension geometry. So it is not supporting the vehicle load or the weight of the vehicle, but it is keeping everything in alignment for the wheel and tire assembly to track with the vehicle and for the suspension to be supported. On the CJ5 with a solid front axle, we don't have articulation of the suspension traveling through the ball joints, but we also have an upper ball joint and a lower ball joint. The axle housing comes up to here and down to here. And then our steering knuckle mounts to the ball joint up on top and on the bottom simultaneously. So these are both carrying the load of the vehicle. Both of these ball joints are under compression load. Since the ball joint isn't one solid piece of metal, it's considered a wear item. There are wearable surfaces on the inside where the load is carried through the ball stud into the body of the ball joint and then into the component that it's mounted into. We have a grease fitting. So there's grease inside of these. Instead of being riveted into position on the component, the body may be press fit into a control arm or a suspension component. Now, if it has been pressed in, it needs to be pressed out. And oftentimes when these need to be pressed out, they don't want to come out easily. Even using the appropriate equipment and tooling, these may be stuck and resist removal. Sometimes heat is used to help a component expand its press fit or break the corrosion bond in between the component and the ball joint. Heat should never be used on a ball joint, and I'll tell you why. This sealed body here has grease in it, and as that grease heats up, it wants to expand, turn into a liquid and vaporize. If enough heat is generated inside the body of the ball joint and enough pressure is created from that grease expanding and heating up and having nowhere to go, the weak point will then become the actual body where it's crimped around that ball socket. This chunk of metal, which is one solid piece, from the tapered stud, from the threads to the stud down into the ball part of the socket, this is all one solid piece of steel. And if that body fails and that pressure from the grease heating up gets high enough, then this crimp around the top of the body here, so where the machinery in the manufacturing process has put a crimp around that ball socket to make it a nice tight fit, if that gives, this becomes a projectile. Not only that, there's an explosion that goes with it. So all that pressure is released all at once, and this goes flying, whether that's straight down at the ground, whether it's down into your foot, down into another part of your body, or somebody nearby. I've seen these take chunks out of concrete on the floor. I've seen them fly through the air and cause damage to other cars. Not only is there a projectile danger, but there's also a danger for your hearing if you're not expecting an explosion like that. So to avoid having an explosion, do not use heat on ball joints. Without anywhere for that grease pressure to be relieved, you are operating on a small explosive with a projectile. As these wear, there will be play in possibly the steering or the suspension or both. A lot of times the wear involved with these comes to lack of lubrication. And if it does lack lubrication, over time these will start developing an audible noise, usually a squeak or a pop or a squeal. And since they operate with the steering and with the suspension, if you're hearing a squeaking noise coming from the suspension and you're trying to locate it, to narrow it down, you can jounce the vehicle to see if it's making noise by this going side to side, and steer the steering to pivot the stud and see if you're getting noise out of it that way. If you're getting both the same squeak from the pivot as you are from the articulation, then it's most likely ball joints that need to be replaced. When I recommend ball joints for replacement, I recommend both sides, even if one is worn. Rather than waiting for the other side to wear out to the point that this one would be, I recommend them both at the same time. Both sides at the same time. So I try to address most chassis components in axle pairs. There are certain systems like brakes that we have to do things in axle pairs for the longevity of the system and the safety of the vehicle. Also, if one of these fails, recommend all ball joints, because you don't know how close to failure the other ones are. We don't have crystal balls yet, and until then, I'm recommending all that I suspect are due for replacement. If I know that 2 have been replaced, let's say the 2 uppers have been replaced recently, and the next ones that go up, and the next ones that wear out are the lower ones, or one of the lower ones, then I'll recommend 2 lowers. But without knowing the uppers have been replaced, I would probably recommend the uppers. And it's always good to inquire with the service writer, or write in your tech notes to inquire with the customer if any of the other ball joints have been serviced, ask for repair history. It should always be an open discussion loop between the technician, the service advisor, and the customers. They should all be in a constant loop of communication so the information is clear. Any previous work, any previous damage, and it's up to the customer whether or not they disclose some of that. Sometimes customers won't give all the information up front, and they need to be asked. It's not that they're trying to hide something. Sometimes they might be. Other times they just don't know. They're not professionals, they're just professional owners. Like I've said before, they're professional owners of their vehicles. So they own it, and that's about as far as it goes for them. So the understanding of the components and the systems really comes down to the service advisor communicating with the customer, helping them understand what's happening on the vehicle and what's being recommended, and the technician helping the service advisor understand what and why certain things need to be addressed and in what priority. So as the ball joint wears out, it's going to develop play. That's going to be up and down play, and maybe side to side play, but any play out of a ball joint out of specification is reason to replace it. If you can see the play, that's usually enough to recommend replacement. If you can feel it, again, it's usually enough to recommend replacement. They should be nice and tight. There shouldn't be any wiggle when you're checking the wheel and tire assembly and going through your tests to look for play in the system. In order to check ball joints for the proper amount of play, the ball joint needs to be loaded. So depending on the location of the ball joint, whether it's a loaded ball joint or an unloaded ball joint, and whether it's under compression load or under tension load, need to be taken into consideration before we determine how they need to be tested. The vehicle should always be raised off the ground so the tire is not in contact with the ground. The ball joint should be loaded. So on a vehicle that has a loaded lower ball joint, the vehicle should be picked up, or the load should be supported by the lower control arm, so we can check that for any play. If it's an upper ball joint, if the upper ball joint is the loaded ball joint, then usually the vehicle needs to be supported by the chassis. So by the factory lift location points, support the vehicle, raise it up off the ground, and you may have to wedge a tool, a specific tool for checking ball joint wear, or a block of wood or something like that to support a control arm before it's resting on the bump stops to check for play. Again, we'll do more of that in lab. Makes a lot more sense in person. The next part we're going to cover is all about bushings. Now, what's a bushing? A bushing is any type of material that's softer than the components that it's mounted to offer insulation or cushion between 2 hard-moving components. In this case, most of the bushings we're going to be working with have a steel outer body, a steel inner sleeve, with a rubber or a polyurethane layer in between. Bushings can either be this type, and they can also be in a configuration like this. This would be a strut rod or a radius rod. This part would anchor around a metal component with a big hole in it, and these rubber parts of the bushing would sandwich in between, and as this nut is squeezed on, or as this fastener is tightened, it provides a compression on those bushings, so the load of the component is being absorbed by the rubber on the bushing and transferring from one component to the other, usually from the moving component to the chassis in the case of a strut rod or a radius rod. Other bushings have mounting holes on them, and the component would be a press fit around the body. These offer movement this way and this way. This is an example of a trailing arm bushing, likely off of a Honda Civic, is what I'm guessing, or a CRV. Now, since they are not a solid piece of metal, they are a wear item. And as that wears, the soft material is going to be the wear item, or the wear component. So this is an example, I believe this is off of a Subaru rear suspension, of where that rubber has worn to the point to allow the inner sleeve to contact the outer sleeve. This would likely result in squeaks, pops, rattles, vibrations, and similar concerns from the person driving the vehicle. Here are two similar design bushings. Different applications, but the idea is the same. The outer portion of the bushing would be pressed into a component and likely pressed all the way down until the flange meets the component. And then the bolt that goes through the sleeve tightens the component to the inner sleeve. So here's one that is in new, good condition. No cracks, no splits, no tears. Inner sleeve is not touching the body. And this one shows the typical type of wear that you'll see on suspension bushings. So we have a lot of cracking, some chunks and flaking. When this was in the vehicle, you can probably guess that this sleeve was starting to move its way towards the outer part of the bushing, given the condition of the rubber we have here, and that's a little off center. It looks like it's being pushed. And then on the back side, you can see the deformity happening from the components wearing, and this rubber layer here wearing out, becoming brittle, and cracking and tearing. So on this example, we have 2 points of contact in the rubber bushing. And in there, you can see this starting to shear or separate. And that's from the bushing being moved through its serviceable life and the rubber wearing out and eventually cracking, and those cracks developing into larger cracks and eventually developing into tears. It's best to catch a bushing when it shows cracking and recommend replacement at that time, rather than waiting for the component to fail altogether. Here's an example of a lower control arm. We have a tapered hole out on the end where a tapered ball stud would connect to it, likely for the lower ball joint. We have 2 holes here where the radius rod or the strut rod would help stabilize it fore and aft. And then you have the inner pivot portion for the lower control arm. The strut or shock would likely mount to this bushing here. So we have a bushing out near the ball joint, and we have a bushing in at the pivot point for the suspension for the travel of that lower control arm. So I want to cover something about the bushings and how they're supposed to be tightened in a vehicle. So once installed in the vehicle and tightened to specification, this vehicle suspension has deflection at each bushing point. So these are not rigid mounts across the pivot. These are meant to insulate noise and vibration coming from the road to the chassis, so the driver experiences less vibrations and noise in the cabin. It also makes the ride a little smoother, but it offers some play. And anytime you have play in a system, you have the opportunity for irregular wear. So they're engineered to a certain level of deflection. When a component with a bushing is tightened to spec, it needs to be done so with the vehicle weight on that component. So that component needs to be in the position that it will be when the vehicle is sitting on the ground. Let's talk about why that needs to be. Bushings twist. So there's amount of deflection one way and amount of deflection the other way. Its neutral point rides right in the middle. So this bushing in its resting position doesn't have any torsional load on it, which is ideal for having it installed on a vehicle at curb height or trim height. So if we were to replace a suspension component like this lower control arm, and the suspension was at full droop, hanging from the vehicle before we put the vehicle on the ground, and we tighten that to torque spec, then when you rest the vehicle on the ground and it's now sitting on the ground, this bushing wants to return to its normal resting position, which is down here, rather than where we want it to be at resting curb height of the vehicle with the suspension on it. What's going to happen is if this isn't tightened correctly and the vehicle goes out the door driving with the suspension with the bushing loaded like this, it's going to cause that bushing to be under constant torsional force. And eventually what that's going to do, and it won't take long, is that bushing is going to fail. It's going to tear prematurely because it is constantly being held under load rather than being at a nice comfortable resting position. Let me show you a better example of this. Here's an example of an upper control arm, much like the one on my Datsun. I think this is off a Nissan. The bushings are tight and they don't allow free movement of the upper control arm. In order to gain free movement, like when you're working on a vehicle and you need the suspension to move, might be a good idea to allow yourself a little less work and allow for some pivoting action instead of fighting the bushings that are on a vehicle. In order to do this, this is mounted to a mounting assembly. This control arm pivots on a rod that goes through the assembly, and then that rod is actually mounted to the chassis and is there for alignment purposes. So this gives us a good example. If we loosen the pivot bolts, now watch what happens when there's no load on the bushings. Without the bushings tightened, they're just sliding in between. So that inner sleeve is not being... So this inner sleeve is now just rotating on the pivot bar assembly. Normally, when it's all tightened together, that twisting motion is being carried through the rubber layer of the bushing. So here it is pivoting. Once the vehicle's weight is loaded back onto the component, then these should be torqued back to specification. Click, click. So whatever angle this is at when it's tightened to spec is the angle that this component wants to rest at for the bushings to be in their neutral position. Neutral meaning they're not loaded up, they're not loaded down. So as we're servicing suspension components and doing alignments and different things, that is going to be when tightening these to specification with the vehicle load on the suspension is critical. Because the longer those are held in their loaded position, which should only be during bumps and jouncing and compression of the suspension, that should be the only time these are loaded. Other than that, they should be in an at-rest neutral position. Pivoting bushings are always torqued with the vehicle weight on the component. That way they're resting in their neutral position with the vehicle sitting at curb weight on the ground. Sway bars, or anti-roll bars, hey Wheeler, they are another component of the suspension system that aids in vehicle stability. We'll cover the job that they do in a later video, but how they mount to the vehicle is done so through links and bushings. One end will connect to one side of the suspension, and the other end will connect to the opposite side of the suspension. So these go from one side of the vehicle to the other side. And the control arm will connect to one end of it, and the main section of it will connect to either an axle or to the chassis, and then the opposite end will also connect to another moving suspension component. This is a popular sway bar end link design. So this would mount to a component on the suspension, and this would mount to the end of the sway bar. These are made up of a long bolt with a washer on one end supporting the back half of one bushing, and the other bushing, these are going to sandwich around the sway bar or the control arm that it is attached to. Then we have another washer supporting the bushing here, then a sleeve in between, and then the same exact setup on the opposite end, all mounted onto one long bolt. The sway bar should be able to move up and down with the suspension smoothly with the travel of the suspension. So as the vehicle hits a bump, it should be able to go up and down just fine. So right here where my hands are likely going to be the location of the mount bushings. So the mount bushings stabilize the stabilizer bar across the chassis, most often on the chassis. They could be mounted to the axle, so pay attention to where these are mounted. Oftentimes it's the chassis. So you'll have mount bushings holding it to the chassis. And the job of this sway bar is to keep the body from rolling too far one way versus the other during uneven road conditions, on hills, side hills, and when cornering, mostly when cornering. That's done so through these legs that come off on the ends where it's bent. And being tied to the suspension, what this is going to do is along this long part here, it's going to twist like a torsion bar. And it's going to allow each end to move while keeping tension anytime it's not in the neutral rest position. So the suspension allows it to move up and down, or the bushings allow it to move up and down, and it's not under load. It's only under load when one side is being deflected against the other. So when you're turning, and you're turning like this, or you're turning like that, it's counteracting that force to help bring it back to a more rigid, straight position, increasing vehicle handling by keeping weight on all tires, or as much weight on all tires as possible. If the vehicle were to lean too far, it starts picking up the weight that goes to one side of the vehicle. So the stabilizer bar is there to resist that body roll and help those tires that are being lightened to keep weight on them and improve handling and safety of the vehicle. And the bushings that mount it to the chassis, or the sway bar mount bushings, we have end links that connect the ends, that link the ends to the suspension. Those are end links. And then we have the mount bushings. And those mount bushings can also wear out and should be inspected for wear as well. Something to keep in mind as we're covering more of these suspension and steering topics is the three tools that are going to be most important. Your most important tool, first of all, is your brain, your noodle. You got to think. Looking at how things are configured, assessing what the condition is, identifying whether something is going to rapidly and dangerously unload if you remove a bolt or a nut. So use your brain, number one. The two other tools go hand in hand. And that's not really a joke, because one of them is a large hammer for striking, and the other is a large pry bar. And when I'm talking large hammer, I'm not referring to a physically large hammer like a dead blow, because this does not transfer shock the way you need a normal style ball peen hammer. So, big hammer, and if you can swing it safely and accurately, an even bigger hammer. So this is a 3-pound sledgehammer. This is a 2-pound ball peen hammer. And the other tool is a large pry bar. One of my favorites is this one. I think is made by Gear Wrench. Yes, this is a Gear Wrench indexing pry bar. So on this little raptor claw here is a button, and you can change where that pry goes. These are extremely useful. This is the one I reach for first, and if I can't handle the job with one of these, then I have to get creative with another one. The other type of large pry bar. Large pry bar. 3 feet. Take something like that. So most importantly, use your brain to avoid injury in a dangerous situation when working on steering and suspension components. A lot of these items can be under spring load pressure. Even with the vehicle weight off the ground, you can still have a loaded spring. Big hammer for proper strikes to break stuff loose and move things. Hard, accurate strikes with the large hammer will help you immensely. And finally, a large pry bar. Heavy components, chassis components, components that support vehicle weight and load need to be moved and align holes and pivot things down, work against certain pressures, that's when you want to use a large pry bar. Hope you gained a lot from this video. Till the next one, I'll see ya.